Okay, so a couple of items I want to go ahead and make sure brought to your attention. What is happening on Monday? That's the big one. Okay, the test is going to cover rational inequalities, meaning sign charts, graphing and analyzing rational functions, and it's also going to cover composition of functions. You got the homework on that today. It'll be due Friday. That way we'll get it turned in just prior to the test on Monday. I did mention yesterday that I was going to upload a problem that was very similar to your sign chart problem on the test, because this one is going to have you write the inequality yourself, okay, simplify it, and then create the sign chart. So if you come on over to the website, here's the current week, 9/11 to the 14th. All right, exam 2, rational inequality. Okay, so here's a word problem. It's already got the answers, and I've got my work here that shows you how we got that. Okay, so sometime, between now and this weekend, I would log on, take a look at that. It's really going to help you out when it comes to the test. If you have any questions, come talk to me about it. All right, so we got the test coming up. What is happening tomorrow? Okay, we have a quiz over graphing rational functions. You're going to sketch one for me, find me some items, vertical, horizontal asymptotes, zeros, all that good stuff, the intercepts. So that's coming up tomorrow. Uh, there is this that I've been working on, and I think I'm ready, so I'm going to go ahead and talk to you about it. If you go to the Google Store, Google Play Store, or wherever you like to go ahead and get your apps from, you'll probably be very interested to go ahead and download the McGraw-Hill app, okay, specifically the Connect Ed one. All right, now McGraw-Hill is the publisher of the textbook that we use in this classroom. And if anybody is interested in getting a digital copy of the textbook, it comes with instructions, it has extra problems, it has a review, all kinds of good stuff come along with it. I believe it might even have video tutorials on certain concepts. So you're going to need an internet connection to go ahead and make the download. But once you download it to your phone, your tablet, whatever your device is, you have it on that device from that day forward. Okay, so what you'll do at some point, go ahead and download the McGraw-Hill app. Then you're going to come to me. I'm going to log on to their website. I'm going to find what your specific username and password is. I'll give those to you, and then you can log on using the McGraw-Hill app. You should be able to download what you need. Okay, so if anybody's interested, just go ahead and do that for me. Okay, Connected McGraw-Hill. So let's see. We talked about the test. Let me go ahead and pull this up. Here's our next focus activity. Now remember, the end of the 6 weeks is next Friday, so we have just over a week before the final grades are going to be submitted. This is definitely going to be one last grade you want to take care of. We're going to be turning the focus activities in next Wednesday. Should be a guaranteed quiz grade. At that time, you'll have 3 of them, numbers 4, 5, and 6. You'll get number 6 on Tuesday. Okay, so let's go ahead and take a look at it. During a 2-week period, Muriel took an umbrella with her on 8 days. It rained on 9 days, and Muriel took her umbrella on 5 of the days when it rained. Display this information on a Venn diagram. Okay, so let's see here. All right. Well, we know that there were days where she both took her umbrella and it rained. So I'm going to go ahead and draw a couple of overlapping circles. Now we use U for the universe, so what would you like me to use for the days she brought her umbrella? Just so we don't confuse the two. B-U-M? Or U-M? Okay. So U-M, there we go. For umbrella. And then we'll go ahead and say R is the number of days that it rained. So let's see here, how many items belong to this universe? There we go. See, it's over a 2-week period, and I just didn't want to go ahead and just immediately say days, because that would kind of give it away. So we've got a 2-week span here, 14 days. So what do I know that I can start plugging in here? Like, do we know how many days it both rained and she took her umbrella? That's 5. Okay. So I'm going to put 5 right here in the middle. But I know that it rained a total of 9 days. So how many days did it rain, but she did not take her umbrella? 4. Okay. Do we know the number of days she brought her umbrella? Okay. Well, now, 8 total, but 3 She brought her umbrella and it didn't rain. Okay. Now, am I missing anything? What am I missing? There you go. If I add all those, I've only accounted for 12 of the 14 days. So somewhere, outside the sets in the universe, I still need to have a 2 because we got 14 days total. Okay, so that takes care of A. Now, B1. Find the number of days that Muriel did not take her umbrella and it rained. So let's translate this from a sentence into a mathematical expression. So B1. So let's see. Muriel did not take her umbrella. What's that trying to get us to think of in terms of sets? Starts with a C. Complement. There we go. We were talking about everything in the universe, but not in that particular set. So because represents our umbrella, okay, I'm going to say she did not take her umbrella, and what's that? Union or intersection? What's that? That's the intersection, okay. So the number of days that she did not take her umbrella and the intersection of it raining. What was the key word for a union? Or. There we go. Okay. So let's see here. Looking at my Venn diagram, how many days did she not take her umbrella and it rained? 4, yeah. Does anybody want to have me look at that in the Venn diagram? Anybody want me to shade that? Okay, you want me to do that?
No, I have a question.
Those would represent days where she did not take her umbrella and it did not rain. Okay. Because see here, we know that 3 days she took her umbrella, but what? It did not rain. We know 5 days where she did take her umbrella and it did rain. And we know that 4 days it rained, but what? She didn't bring her umbrella. Okay, so the different combinations that we have here. Okay. Which is kind of funny. I guess she's either not paying attention to the weather, or because it seems like several days where she had her umbrella and didn't need it, or needed the umbrella and didn't have it. So I don't know. Or maybe I'm analyzing it a little too much, Okay. I'm sure Muriel is an intelligent woman. Okay. Let's go on to B2, or not 2B. Oh, there you go. Okay, Muriel did not take her umbrella, so that would be the complement. Did not take her umbrella, and did not rain. And in fact, Jack really just answered this question with his own. So what would this be? Yeah, there was only 2 days where she did not bring her umbrella and it did not rain. So 2. All right. Question. How we doing? Okay. All right. Put that with your other one. Remember, you should have 2 at this point. If you've lost number 4, looks like I have a few copies over here on the door. Those will be there until next Wednesday. All right. Now, there is something I wanted to get to yesterday, but I didn't quite have the opportunity, because last week, you remember I introduced the continuity test. Okay, we started talking about limits. Okay, well, I want to go ahead and kind of talk about that again. Not the continuity test exactly, but just being able to visually analyze a function and be able to tell what's happening. Okay, so this is a paper you picked up yesterday. Again, if you don't have it, I got copies right over here in Tuesday's pocket, because that was the day I gave it. So we got this rational function here. It says 2x squared minus 5x minus 3 divided by x squared minus x minus 6. Now, if the coordinates of the whole are 3 and 7/5, complete each of the following statements with a value. Okay, so the first 2 statements, we're saying as x approaches positive and negative infinity. Now, these are what we call the ends. A lot of times you're going to hear this referred to as the end behavior. So let me answer the door very quickly. Hello. Hey. Okay, so when you're talking about x approaching negative or positive infinity, we're referring to what's called the end behavior. So we're talking about if you're on the x-axis and you travel really far in either direction, you're interested in what the function itself is approaching. Okay, now we also looked at how to write these. So instead of just laying it out like that, you could go ahead and say the limit as x approaches negative infinity of f of x. That would be equivalent to this first statement that we have here. Okay. So can anybody tell me, let's say we get on the negative x-axis and we just start traveling left and I keep going. Well, what's the function doing? Closer and closer to what? Okay, so Jack thinks it's 2. Is he right? It is 2, yes. When you're looking at the end behavior, it's okay. You want to focus on the horizontal asymptote. So yeah, as we go to negative infinity, the function is going to approach 2. So what happens in the opposite direction? If I get on the positive x-axis and I just keep traveling, what's that function going to get close to? 2, but again, it's not going to touch it. There we go. That's what we call the end behavior. Okay, we want to focus on the horizontal asymptotes. Okay. Well, now the next two, as we approach 3 from the left and the right. Now, is 3 the asymptote or the whole? This one's the whole, the removable discontinuity. This one's been a little tricky for people today. Let's focus on the left. As I approach 3 from the left, so think about it. Maybe, 2.5, 2.9, 2.95. As I start getting really close to 3, I'm going to have y values that are approaching what? What's that, Christian?
Oh, well, the asymptote.
It's not going to approach the asymptote. See, we've already accounted for that. Heard somebody say it. It is going to approach 7/5. Now remember, this is one of the things that we brought up the other day. The function is not defined at 3. If I go ahead and plug 3 in here, I'm going to get 9 minus 3 minus 6, which is 0, which is why we have the whole. So if I were to factor it, we should be noticing a common group factor, correct? Okay. But even though the function is not defined at 3, okay, we still have a limit that exists. The y values are still going to approach 7/5. Okay. What do you think is going to happen from the right? Well, let's see. As I get closer to 3, so maybe 3.5, 3.1, 3.01. What are those y values going to be approaching again? It's still 7/5. We're just approaching the same point from 2 different directions. Okay. Now, -2, that's my vertical asymptote. Now, when you're analyzing a vertical asymptote, as you approach him from both sides, there's only 2 options. The graph either wants to climb to positive infinity or go down to negative infinity. Okay. Now, remember, there was also a specific way we wrote this. Like, let's look at -2 from the left. We would say the limit as x approaches -2. Now, how would I write it so that if somebody were to come in and read my work, without actually saying from the left, they would know what direction I'm coming from? Okay, Christian says it would be a minus. Right there where a power would be, okay, if you put a negative, that means we're approaching it from the left. So what approaches it from the right? A plus. Okay, there you go. So we would write that statement there. So that would be the same as what we're currently on. All right, well, what's happening here? As I get close to -2 on the left, well, what's the graph deciding to do? There you go. See, will I ever hit -2? No, there's a problem. Again, -2 makes the function undefined. But I can get infinitely closer. So as I get infinitely close, the graph is going to continue to climb infinitely high. What about as I approach -2 from the right? This one goes to negative infinity. See, I'm getting close on the right, but now he's chosen to go down. Does anybody have any questions on these? Okay. Now, the only thing left is the domain and the range. Okay. Being in math class, I would think that, domain is one of our favorites because we do function well in our domain. Okay. You'll laugh later. Trust me. Okay. Anyways, now let's go ahead and write these first one out using interval notation. Okay. So let's see. Jane, what values of x do I have to exclude from the domain for whatever reason? Okay. 3 is one of them. There's one more. The negative 2, okay, because we have a hole in a vertical asymptote. So if I were to write this out, I'd say negative infinity to negative 2, union, negative 2 to 3, union, 3 to infinity. Okay. Now for the range, I want to do the same thing. I'm just moving vertically. What are the y values I've got to throw out of there, Dylan? 7/5 and 2. So the range is going to look very similar as far as the layout. I'm just going to replace negative 2 with 7/5 and the 3 with 2. So negative infinity to 7/5, union, 7/5 to 2, union, 2 to infinity. And there's probably someone out there thinking, well, isn't there a quicker way to write that? Okay, there is an equivalent way. What am I referring to? I could say all reals except, and then we would just say, x can't equal, y can't equal. That would be fine. Okay. All right. So it took us, a few minutes to go ahead and walk through that, but I'm hoping now that we see another one and another one after that, it starts to go faster because we know what it is we're going to be looking for. Okay, so let's try this one. So we got another rational function. Okay, this one is x squared plus 4x plus 3 over x squared plus 2x minus 3. And we have a hole at negative 3 1/2. Okay. So as we approach positive or negative infinity, what do we call that again? Two-word phrase started with E? The end behavior. That's what we refer to as the ends. Okay, so if you ever hear that, that's what we're referring to. So as I approach negative infinity, well, what's the function approaching? Remember, for the end behavior, what do we want to look at? The horizontal asymptote. So what's my horizontal asymptote? 1. So as we approach negative infinity, g of x should be approaching 1. What about as we approach positive infinity? It's still approaching 1, right? Now, if you take a look, on the left, we're approaching 1 from below. On the right, we're approaching 1 from above, but that doesn't make a difference. We're still approaching the same value. Okay, now negative 3 is my hole. As we approach negative 3 from the left, what does g approach? The 1/2. There we go. Just like we said, even though the function is not defined at negative 3, the limit will still exist. We are approaching that y value. So it's going to be 1/2. The same from the other side. As x approaches negative 3 from the right, g will still approach 1/2. Okay. What about the vertical asymptote? As we approach 1 from the left, what will g approach? Negative infinity. As we get infinitely closer, okay, the graph is going to get infinitely smaller. So this is negative infinity. What about as we approach 1 from the right? Positive infinity. Okay. Is everybody getting the idea? Anybody confused? Okay. Well, let's see here. Let's go ahead and write out the domain and range like I mentioned a moment ago, instead of using all the interval notation. So I won't even say all reals. I'll just go ahead and put the double R. So all reals except x cannot equal, well, what do I have to throw out of the domain? Negative 3 and 1. Okay. And then for the range, I can go ahead and say all reals except y cannot equal what? 1/2 and 1. Okay. What do you guys think? Okay. Good. Now, we're not going to go ahead and run through all 4 of these. You've got a couple of extra that you can take a look at, in your spare time. If you want to, you can come talk to me about it if you have any questions. But we're going to see limits kind of sprinkled throughout the curriculum as we move forward, especially, again, when we get into trig. So I just, want to keep these ideas kind of fresh. All right, so we are talking about composition. All right. And we spent yesterday, we were talking about composition using a table, then we used graphs, and now we are currently to functions using the equations. Okay, and I don't remember how far we got. What did we get done yesterday? So we did get numbers 1, 2, and 3 done. but we didn't get task 1 done. Okay, good. Then one thing I just want to go ahead and kind of remind you of right here, when we're talking about composition, like this number 3 right here, P of G of -1, the way we say it, the output, okay, the Y value for the inside function must be in the domain of the outside function. Remember on number 3, we showed that didn't work. You always evaluate these from the inside out. Now, there was another way to write these. How did I show you yesterday? What was the symbol? Yeah, like a little circle. So P of G of -1, this is the same as P composed with G of -1. So that little circle means composition. Okay, so it's just another way that you could potentially see it, depending on textbook or your teacher. But I believe our textbook does do it this way here with the parentheses. Okay, so I want to go ahead and kind of extend on this idea and do one more thing. It says task 1. I'm given 2 functions here, quadratic and a linear, and it says find f of g of -2. Okay, so this is just what we finished with yesterday. So which one do I evaluate first, f or g? G. Always start with the inside and work out. So g of -2, all right, so 2x plus 1, I'm going to replace every x with -2, and what's that give me? -3. And this is what I was referring to. The output, okay, the answer I get for the inside function has to be in the domain of the outside function if this is going to work. Well, think about 2x squared minus 3x plus 2 for a second. He's quadratic. What direction does he open? Up or down? Up, because the 2 is positive, right? But how wide would he get? What's his domain? Everything, so all reals, right? So this composition is going to work out just fine because -3 absolutely belongs to his domain, unlike that previous one, number 3, we were just looking at. So I'm going to take -3 and I'm now going to plug it into function f. So f of -3. So 2x squared, 2 times -3 squared, minus 3x, so minus 3 times -3, and then plus 2. So let's see here. -3 squared times 2. 18 plus 9 plus 2. 29. There we go. Okay. Excuse me. I just need to check this. My father's going in for an angiogram today, so we're all kind of nervous about that. I just want to see if anything's going on. Okay, so right now they're at the hospital and they're waiting, so I hate those hurry up and wait texts. I can't do anything but wait. All right, so is everybody okay with where I got 29? Okay, we're good? Okay. Well, now task number 2, it says, okay, we're given the same 2 functions, but now it says find an equation for f of g of x. So if I weren't to say find an equation, you would still know that's what you want, even if I just said, for instance, find f of g of x, because there's no numerical value you're given. Okay, so if you're given x, you are going to plug one equation directly into the other. Now, am I going to plug f's equation into g or g into f? There you go. The inside function is what I'm going to plug into the outside function. Now, you'll notice there are multiple x's here. So I'm going to have to plug him in for every one of those. So f of g of x. So 2x squared would be 2 times 2x plus 1 squared, minus 3x, so minus 3 again times 2x plus 1, and then plus 2. Is everybody okay with what I'm doing? So this time, instead of plugging in a value, we're plugging in the entire equation. And now this is why I'm thinking it's just going to be a really easy day. This just goes back to Algebra 1. We're talking like terms, distribution, all kinds of things like that. Now, 2x plus 1 squared, if anybody needs or wants to go ahead and write it out, and then you'll go ahead and multiply by FOIL, that's perfectly fine. What's FOIL? First, outside, inside, last, right? Well, I've got a way that I think is faster, and I kind of use it. It's one of those, again, silly ways, but it does work out. Okay, it's a little rhyme. Square the left, square the right, you double the middle, you got it right. And really, I don't even think it should be called a rhyme because you're rhyming the same word with itself. So, maybe we could change something. Square the left, square the right, double the middle. It's out of sight. Or math takes flight. Or I see the light. I don't know. You can make up your own thing. But let me go ahead and show you how this works. The left term is the first term in the binomial. The right term is the second. So square the left. What do I get if I square 2x? 4x squared. Now square the right. Plus 1, because 1 squared is 1. Now double the middle. This is where I multiply the two terms together. So 2x times 1, and then I double that. So that would be 4x. Now, if you FOIL, you're going to get the exact same thing. Okay. I just think it's a lot faster, and you're able to see exactly what's going on. Okay. But however you want to do that, that is completely up to you. Now, we still need to go ahead and distribute a 2, and I'm not going to go ahead and distribute this 3 just yet. I'll go ahead and distribute all at the same time. So what do I get if I double that quadratic? So 8x squared plus 8x plus 2 minus 6x minus 3 plus 2. There we go. And now we just combine our like terms. So the squared stays the same, but how many x's do I have? 2 x's, okay, so plus 2x. And then 2 minus 3 plus 2 plus 1. So there we go. That equation will represent the composition that we were just working with. Instead of just plugging a value through the two functions, I came up with a function itself. Now here's what it wants me to do on task 3. It says use the equation that we just found, this guy right here, to find f of g of negative 2. What do you think is going to happen? Or let's see. We'll see. So this is what we found for f of g of x. So now I want to use this and evaluate f of g of negative 2. So every one of these x's I'm going to replace with negative 2. So 8 times negative 2 squared plus 2x, 2 times negative 2 plus 1. So let's say negative 2 squared times 8. So 32 minus 4 plus 1. 29. Okay, what am I wanting you to see here? Yeah, whether you chose to evaluate the functions individually or used an equation based on the composition, you should be getting the exact same answer. See, we got 29 here, 29 here when we did them separately. Okay. Good, good, good. Now, before we move into the next section, just want to go ahead and show you this very quickly. We are able to go ahead and perform operations with these functions. Okay. Now, remember, if there's the circle, remember that means composition. Okay. But whatever operation you're given is what you go ahead and perform with the functions. So if you have f plus g of x, well, you want to add the two functions. We call that the sum property. Then we also have the difference, the product, and the quotient. With the quotients, one restriction, the g of x can't equal 0 because we can never divide by what? We can never divide by 0. Okay, so we'll kind of keep these in mind. We're not going to look at them just yet. We have a few more composition problems to take care of, and then we'll go ahead and start to see that. But again, really, it just boils down to the algebra. Okay, so there's really nothing new here. All right, let's look at the first one. It says find an equation for g of h of x. So I'm not finding an actual answer here, or I should say that my equation will be the answer, not a numerical value. Okay, so am I going to plug g into h or h into g? H into g. I'm going to plug the inside function into the outside. So I want to take this equation here, and I just messed myself up. I want to take this equation here and plug it into g. Okay, so g of h of x, okay, equals, so 1 minus 2x, but instead of x, I'm going to put the 3/2 x minus 2. So I plugged h's equation directly into g. just like we did a moment ago. And now we just simplify as far as we can. Okay. What do I get if I distribute the negative 2? So negative 3x plus 4. Okay, so it looks like my equation is going to be linear, negative 3x plus 5. Okay. So would anybody like me to just choose a number, plug it in, do it individually, and then use this equation just like we did to show you that either way you're going to end up with the same answer? You trust me? Okay. All right. Well, let's try B. Find an equation for g of f of x. Now, am I going to plug g into f or f into g? Okay, f into g, because f is my inside function. All right. So, again, I've got function g, 1 minus 2x, g of f of x, equals. So, 1 minus 2x becomes 1 minus 2 times negative x squared, hopefully I have enough room, plus 3x minus 5. Just enough. Okay. So I plugged f into g, and then now we just simplify. Okay. Let's see here. Kimberly, what would I get if I distributed that negative 2? Okay, so 2x squared and 10. There we go. Okay. And then we'll combine our like terms. So it looks like I have 2x squared minus 6x plus 11. There we go. How we doing? Anybody having a hard time? No? Okay. Putting the fun back in function. Okay. I'm sorry, what?
Never mind.
All right. Okay, let's try another one. Find an equation for f of g of x. Okay, so I'll get this one started, and then let's see if we can't get somebody up here to help me finish. So this time I'm going to plug g into f, and there are multiple x's where I got to replace x. Okay, now remember the negative is still going to be there. I'm just replacing x. So f of g of x equals. So negative x squared will become negative. Now I'm going to put 1 minus 2x squared. See, all I did was replace the x. Plus 3x, so plus 3 times 1 minus 2x. And then we have minus 5. Okay, now I just need somebody to come on up here and take over for me. Jack, you want to do it?
No, I just have a question.
Oh.
Your outside, inside.
Uh-huh.
Does that require that the x term or the term that has the x in it be in front of?
No, does not. So Jack?
Then, all right.
Huh? I can tell Jack's tempted. Come on, what's the worst that can happen? Yay! All right. There you go, sir. Thank you. And while he's doing that, I'm going to go ahead and pass back some papers. No, you're right so far.
I was just scooping it down.
Oh, okay.
I don't know. Wait, when you square the middle, just multiply by 0.
Yeah, so double the middle, multiply the two terms together, and then double that. Sorry.
Multiply these two.
Yeah, so 1 times negative 2x, and then double that.
Oh, okay. That's weird. All right.
Yep. There we go. Okay, good. He went ahead and distributed the -1 that was outside as well. So we had 3 minus 6x minus 5. Okay, what do you guys think? He says -4x squared minus 2x minus 3. That looks good to me. Excellent. Good job. So that would be the answer we're looking for. Okay. Yes. That's multiplication. Mm-hmm. Okay, so it was. All right. So I'll finish passing the rest of these out in just a second. So there's Raphael. Okay, good. Anybody having a hard time with these? Any questions? Okay. Would you like to go ahead and try D, or you feel confident we can move on? Is there anybody who would like to do that next one, D? Okay, don't let peer pressure affect you. Okay. It's peer pressure from me? Okay, well, it might be a type of pressure, but I don't say it'd be peer pressure. Because, you know, I'm not going down to the cafeteria and hanging out with you guys. That would just be weird. You guess? Okay. All right. All right. Well, maybe one of these days, Jack, I'll mosey on down to the cafeteria and be like, what's up, partner? And you'll be like, what are you doing? You wanted me to come down here and hang out with you. I'm your peer. Okay, that's it. Okay, no, you're not going to say anything. All right, next up. Now, I do want to go ahead and point out that, you know, if I do make a mistake, I will own up to my mistake. Okay, even though I say, you know, a lot of times I would just say if you were paying attention, because it is a great strategy. But this was not my resource. I do know my alphabet, how it goes E, F, and then I, J. I did not do that, just in case anybody was out there thinking that. Okay, that was not me. All right, but next up. So starting with E, we go ahead and start looking at just working with the functions themselves. So E is not a composition. -6x times h of x minus f of x. Okay, so all I want to do is substitute in the functions that I have. So I have the -6x times, now I don't remember what h of x was. That was 3/2 x minus 2. And then I want to subtract the quadratic. I think that's the -x squared plus 3x minus 5. -x squared plus 3x minus 5. Okay. And I would recommend, especially if you're going to subtract a polynomial, always put parentheses around it, because you don't want to forget you're subtracting every term in that expression. So in order to drop those, you would have to distribute. Okay. So let's see. If I distributed that -6x, what am I going to get? Okay, -9x squared plus 12x. Okay. Now over here, we're just going to be changing the sign. So plus x squared minus 3x plus 5. Okay. And now what? Okay, so -8x squared. What? Plus 9x. Okay, plus our 5. There we go. Perfect. Okay. That's it. Now, f, okay, says find an equation for f times g of x. Okay, so this isn't a composition. We actually want to multiply the two functions together. So again, it's just the distributive property. Okay. Now, because g is a binomial and f is a trinomial, I've just always done it the smaller times the larger. I mean, you can do the other or. It just seems weird to me. But I'm going to go ahead and put the 1 minus 2x times, what was it? -x squared. Was it plus 3x minus 5? Sounds right to me. Okay. So all I want to do is multiply those together. Okay, so just, real quick. So who wants to come on up and try this one? Okay. Or since we're almost out of time, okay, how about we do this? Jack, you were the last person to come up to the board. Who would you like to see come up and do this problem? Like how nobody's looking at Jack right now, not making eye contact.
Up there.
Who's going up? Skylar. No, come on, sky's the limit. All right. All right. Thanks, sir. All you're doing is just multiplying those together. Just basic algebra. Okay, I got a few more papers to pass out. Let's. Okay, there's Connor. Okay. So the 1 is going to give me the same thing. Plus 2x squared minus, or cubed, I'm sorry, minus 6x squared plus 10x. Okay. So 2x cubed minus 7x squared. Looks like we've got 13 x's and then minus 5. What do you guys think? Okay, looks good to me. Perfect. Perfect, perfect. Okay. Good. Now, for what value or values of x is f of x equal to g of x? Okay, so graphically, we're just looking for the intersection between a quadratic and a linear. So at most, how many solutions could I have? Think about a parabola and a straight line. How many ways could they intersect? Okay, yeah, the maximum you're going to get is 2. Okay, could be no solution. Maybe they don't cross at all, or maybe they only cross once. So let's see. F of x was the negative x squared plus 3x minus 5. And we're going to set this equal to, was it 1 minus 2x? Is that right? Okay. All right, now I've got 1048. What do you guys think? Should we go ahead and push forward, or should we go ahead and stop for today? Nobody wants to be the one to say anything. Susie, what do you think? I'm sorry? We should stop? Okay. I'll do that today. All right. So remind me tomorrow, this is as far as we got. We'll go ahead and pick up there. So we'll finish this up. When's the homework due? Friday, okay. And then the rest of the time tomorrow, we're going to have our quiz. Now, don't forget, we also have the young woman from Texas Tech. Did I mention this? Okay, I don't know if it's going to be just this semester or the rest of the year, but on Thursdays, I'm going to have a student from Texas Tech University. She's going to come in here. She's observing, learning to be a teacher. So she's going to be probably every now and then teaching you guys, grading papers, doing all kinds of things. So basically, I'm going to be showing her the ropes, what it is to be a teacher. Okay, so we definitely don't want to scare her off. Okay, we want more people in our profession. Okay, all right, but